Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. My name is Associate Professor Dr. Ahmad Mazim Hilmi. In today's video, we are going to continue about the topic from chapter 17, belting. From belting from the book Shigleys Mechanical Engineering Design. Okay, so we continue from the previous slide, from the previous topic. Okay, I'm using this book, Shigleys Mechanical Engineering Design, chapter 17, Flexible Mechanical Elements. This is the second video for the topic. Okay, if you it's better have the textbook with you so that you can refer what I'm saying. Okay, so in today's video, I'm going to talk about the equation related to the belting. Okay, so you can see in the slide here the flat belt geometry. This is the open belt. You can see the equation is related to it. Okay, this is the basic equation related to belting. Okay, notice the symbol that appear in the equation. Okay, they are theta d, theta capital D, theta small d. Okay, pi minus 2 sin negative 1 d over minus d over 2 c. The way you learn, you have to alert where is the location of the symbol. For example, the small d is the small gear. Okay, d is the capital D is the bigger gear, meaning that if you have two motor, two gear, two engine, okay, the smaller one is diameter, small diameter is the smaller one, the big diameter is the capital D is the bigger one. Okay, and then the pi d. Okay, the pi d and the c is the location from the center distance, from the one distance until this distance. This is the c. And then the equation, the theorem Pythagoras equation, if you remember, for c, this is the theorem Pythagoras equation for c, capital power of 2 minus d over the small d capital 2. Okay, so this is the theorem Pythagoras. You can get the location of d lah. Okay, and then this is another equation for the cross belt. Previously is the open belt. This is the cross belt. Okay, the equation is pi minus theta equals to pi plus 2 sin power negative 1 d plus d over 2c, and L is the length of it, is just the same as the previous one. For c, capital 2 minus d plus d, capital 2 plus half d plus d theta. Okay, so again, be alert to the location of all the variables. It's better that you draw again, that you take a pen, write again in a piece of paper where is the location of the symbol, so that you may understand. Okay, you may understand this is how you learn from this subject. Okay, and then there are types of belts. There are reversing belts. Okay, with bike that can reverse. You can see example in your bicycle. Okay, they have the reverse. If you pedal the refront, if pedal back, it can reverse. Okay, and okay, this is the reversing belts. Okay, this is the flat out of plane pulley. Okay, you see this is the point of the pulley. Okay, this point of the pulley, this is the out of plane, because it's not in the same plane of the pulley. It's slightly to the left and to the right, to the up and to the down. Okay, it is called the out of plane pulley. Okay, and then flat belt shifting without clutch. This is the loose pulley. This is the ribbon. This is the shift fork, and this is the driver. Okay, driver meaning that the motor is attached to to the mechanism, and then it move, and then the driven one, it will follow suit lah. Okay, and then this is the variable speed belt drive. This is there is a fork inside it. Okay, which means that you can see the mechanism, uh, it is tapered. It has tapered. Okay, this has tapered, meaning that you can see this geometry is has tapered, meaning that it can be faster, it can be slower, be adjustable with this one. Okay, this one. Okay, so we see the textbook. Okay, we see the textbook. Okay, this is what you have shown in the slide before. The flat belt geometry, open and cross belt. Again, I advise you to take a piece of pencil and write it again, draw it again, so that you will remember the location of the geometry. Okay, and then this is the cross belt. Okay. This is the no reversing and reversing belt drive. Okay, no reversing open belt, reversing cross belt. Cross belt must be separated to prevent rubbing if high friction materials used. Of course, this is the cross belt. You can see here, this is a cross belt. You need if you contact, if you have friction, it will cause wear and tear to the system, and then you have to replace it faster. Okay. Okay. Figure 70.3 shows a flat bike drive with outdoor plane pulley. The shaft need not be at right angle. In this case, most of the top view on drive is figure 17.3. The pulleys must be positioned so that the belt lift is fully in the mid plane of the other pulley face. Other arrangement may require guide pulleys to achieve this condition. Okay. Another advantage of flat belt is shown in 17.4, where clutching action is obtained by shifting the belt from loose to tight. Okay, or ribbon pulley. Okay, where is 17.4? 17.4, this is the picture of 17.4. Okay, it can be loose pulley, it can be tightened pulley. Okay, it can be adjusted. So flat belts are made of urethane and also rubber impregnated fabric reinforced with steel wire or nylon cord to take the tension load. One or both surface may be a friction before, may have a friction surface coating. Okay, meaning that you want to avoid, you want to reduce the friction will happen. You want to reduce the friction so that the belt can be longer usage. The belts are acquired, they are efficient in high speed, they can transmit large amount of power a lot over long center distance. Usually flat belting is purchased by the roll and cut, and the ends are joined by special kit furnished by the manufacturer. Okay, so of course it is high speed because it only flat, it does not have teeth. Okay, you can see your timing belt, you can see the timing belt, it have teeth. When you have teeth, it has friction, it has more friction, but the flat belts don't have much friction as a timing belt, so it can be used for high speed. Okay, when you purchase flat belting, okay, it has purchased by roll and cut. For example, for the men's, you have your belt. Okay, when you go to the shop to buy belts, also they have the shop will cut according to your stomach. Okay, so there is a belt. Okay, a V belt is made of fabric and cord, usually cotton, rayon or nylon, and it printed with number with rubber in contrast with felt belt. V belts are used with similar sheath and at shorter distance. V belts are slightly less efficient, but a number of them can be used in a single sheath, thus making a multiple drive. V belts are only made in certain length and have no joints. Okay, there is the V belts. And the timing belts, you are familiar with timing belt because every car have timing belt. Okay, timing belt have made rubberized plastic and steel certain wire have teeth that fit to groove into the periphery of the sprocket. The timing belt does not scratch or slip and consequently transmit power at a constant angular velocity ratio. The fact that the belt is toothed provides several advantages over ordinary belting on leaf is that no initial tension is necessary so that the fixed center drive may be used. Okay, uh, no need to tension, no tension. Okay, this is the advantage of timing belt. Okay, so the mission and another one they say another is the elimination of restriction on speed. The teeth make it possible to run at any speed, slow or fast. The advantages and the first cause of that the necessary of grooving of the sprocket and then the net fluctuation caused by belt tooth meshing frequency. Okay, so that timing belt is in the car because they can be adjustable speed, slow or fast. Okay, that is why flat belt they don't use in the car. Okay, they don't use in the car because eventually it will broke down if you use it will cut open if you use the flat belt. Okay, so when using the timing belt, of course you know when at a car it will have dynamic fluctuation, meaning that we go up and down, up and down, up and down. You will drive faster, it will go up. You drive slower, it will go down. And you jump into the hole, it will go up and down, up and down. So that is called the dynamic fluctuation. Okay, caused by belt tooth meshing frequency. Okay, that's all for the video today. See you in the next video. Thank you very much.